All right, here we're going to be looking at section 7.6, and our learning targets are factor ax squared plus bx plus c. You'll see this is a little different because I have this other value in front of my x squared term. We've been working with very similar trinomials, but this has always been a 1 before now. So now it's a different number, so we have to use some different strategies. Then we're going to be using factoring to solve real-life problems. Oops. So let's go ahead and look at this first example. I need to factor 5x squared plus 15x plus 10. So the first thing I notice is that there is a common something in all of my terms, right? So I see that each number is divisible by 5. So I'm going to factor that out first. So I know if I factor out that 5, I'm left with 5x squared divided by 5 gives me x squared. 15x divided by 5 gives me 3x. And 10 divided by 5 gives me 2. So now that I've factored out that coefficient, now I'm left with a trinomial that I've seen before with a leading coefficient of 1. So now I can go ahead and factor this. So first I want to come up with all of my factor pairs of 2, which I know I can have 1 times 2 or 2 times 1. Right? And it doesn't matter which order because my leading coefficient is 1. So when I add them together, I do get 3. So now I can finish factoring. So that 5 has to stay there because it's not gone yet. But now I know I can factor into my two binomials with my terms of being x plus 1 and being x plus 2. So here was a more simple example of what we're going to be looking at. So now here we're looking at example number 2, if you're following along in your book. So factor each polynomial. So I want to look at a first. So I check and see if there's anything that I can factor out of each term. And in this trinomial, there's not. Not all of these numbers are divisible by the same thing, so I have to continue what I'm looking at. So here's what we're going to do. So I have to consider all of my possible factors of my a and my c. And remember that a is always this term with my x squared, this is a, and my c is always this constant term. So I see that these are both positive. So then I know that all of the factors of c have to be positive. So now I'm going to go ahead and use my table to organize data. And when we're dealing with these kinds of polynomials, you pretty much have to do this. There's no shortcut. There's no simple way. It's a lot of guess and check. So I come up with my factors of 4, which can be 1 and 4. And my factors of 3 can be 1 and 3. So I go ahead and I try them. Right? Here's my possible factorization. So I would have my x plus 1 and my 4x plus 3, and then I try it out. And I see that my middle term there, right, because I would end up with 4x squared plus 3x plus 4x plus 3. So my first and last terms we know for sure. So I'm just looking at the middle term, ends up being 7x, which is not the same thing that I was given, so I'm not right, so I know I need to continue. Well, what if I switch the order of my factors of my c? I still leave this as 1 and 4, but I just switch the order here. So let's try it again. All right, so here's my possible factorization, and here's what my middle term is. And that ended up working. But let's go ahead and try this last one. So my other possible factors of 4 would be 2 times 2, and I can have 1 times 3. The order here doesn't matter because these are both the same number, right? It's when the numbers are different here, like 1 and 4 are different, that I have to switch the order and try it again. But when they're the same, I just have to try it once. So again, I go ahead and I factor it out, how it would look, and I try and I find my middle term and I see that it ends up being x, so 8x. So I look back and I see which one works, so it's going to be this middle one right here. That's going to be my go-to answer. That is my final, and here is my final factorization. So now I've factored it completely. Okay, so let's go down a little bit. So I just rewrote this, right? So when I take my polynomial and I factor it, that's what I end up getting. So now let's look at b. Again, I always want to see, is there some common term that I can take out of all of my terms here? And there's not. So I know I have to just continue with factoring. So again, I want to use a table to organize my information. So what I also notice is that I have this negative sign here. So this negative sign, with this being positive, tells me that both of my factors of this c term have to be negative, right? Because a negative times a negative will get me a positive, but a negative plus a negative will still get me this negative. So I have to keep that in mind a little bit. Okay, so I use my table. I come up with my factors of 3, and here are my factors of 2, right? And I said it has to be either -1, negative, and they both have to be negative. So then I factor it out and I see what I get, and I see that my middle term is not what I was looking for. So then I can switch the order of these two and see what I get here. So now looking back at my original polynomial, I see that my middle term was a -7. So here is my final factorization right here after trying it out. And yes, you do have to write them out and try them every single time. It just takes a while, but that's just how it works. So then I can rewrite it. So 3x squared minus 7x plus 2 equals the quantity x minus 2 times the quantity 3x minus 1. So here we're looking at example number 3. So the only thing you'll notice that's different in this example is that I have a negative sign here, right? And like we talked about in the last section, that doesn't change much. We still have to follow the same steps. And first, my step, right, is do I have a common factor that I can get out of these? Which I don't, so I know I have to use my table to organize things. Right? So I need my factors of 2 and my factors of -7. So my possible factors of 2 are 1 and 2. And my factors of -7 could be a 1 and a -7, right? So then I try it and get my middle term. But then I can switch where my 7 and 1 are with my negative still being on the second term, right? So all I've done is I've said, well, now it's 7 and -1. And I come up with my middle term. I'm not quite done yet because the order, these values are different, right? 1 is different than 2. So now I have to try a third alternative because I could just move the negative sign up front here and try and get my middle term. And then again, I have to try my fourth one, which is the second one with the negative sign switched. And I try it. So now I look back up at my original problem and I see that it's a -5x. So it's really this first one that we've tried. So my final factorization was 2x squared minus 5x minus 7 equals the quantity x plus 1 times the quantity 2x minus 7. So this is going to be example number 4. And the only difference that you'll notice here is that I have also a negative sign here, right? And that's not really going to change anything. We're going to continue to follow our same steps. So the first step I always do is see is there anything common that I can take out of any of these, which there's not. But I always want to deal with a positive x squared term, right? It gets really messy if it's a negative. So I'm going to factor out a -1 from each term. So really what factoring out a -1 means is I change the signs on everything. But I can't lose that -1, right? It still has to go out front here. I don't have to write the 1, I can just write the negative sign. So once I've done that factoring, I end up with a negative out front, and then I have the quantity 4x squared, and then I change the sign, so plus 8x, and then I change the sign, so minus 5. So now I'm back to some of the previous examples we've looked at, and I can make my table and then come up with all of my possible factors of 4, right? So my factors of 4 would be 1 and 4. So then my factors of a -5, I'd have 1 and -5. I'd have 5 and a -1. Well, then I have to try a -1, 5, and then I have to try a -5, 1. Then I really kind of have to do it again because I have a possibility of 2 and 2 for my factors of 4. But here I don't have to switch the order, which one comes first. I just have to switch where the negative sign is, right? Because these are the same, I don't have to do all of the single steps. So now once I've tried all of these and I've factored them and figured it out, I look back and I see that, oh, it's this last one right here. So that is my final factorization right here. So the only thing we did differently is I dealt with that negative sign in front of the x squared first. So it became out here. But you'll notice in my final answer it didn't go away. Here it is right there. So we have to include this in our final factorization or we're not exactly correct. Right? The stuff in the parentheses just tells me what was originally in my parentheses, but I can't lose that negative sign. So here are several for you to try. Please pick a couple. Pick one from each line and try it, especially these bottom ones with dealing with that negative in front. So now we're going to be looking at that second learning target and looking at our real life problems. So the length of a rectangular game reserve is 1 mile longer than twice the width. The area of the reserve is 55 square miles. What is the width of the reserve? So the first thing we always want to do is we want to draw a picture, right? And it's a rectangular game reserve. And the length is 1 mile, so we're going to call this width, right? The width of it. So the length is 1 mile longer than twice the width. So if I multiply the width times 2 and add 1, I end up with the length. So then the area is 55 square miles. What is the width of the reserve? So what I go ahead and do is I set up my equation, and I know that area equals base times height, or length times height, or width times length. These are all kind of the same thing. So I just pick one. I just know I multiply my two sides together to get my area. So I go ahead and I write that out. So I've got W, and I'm going to just switch the order here. So 2W plus 1, and I can do that because I have a plus in the middle, equals 55. So now I'm going to go ahead and use the distributive property, right? So I end up with 2W squared plus W equals 55. So now when I'm solving, I want to get everything to one side, so I subtract my 55 from both sides. So I end up with my 2W squared plus W minus 55 equals 0. And I want to always get it to be 0 over here because of our zero product property. So now I have to factor, right? I have to get my W's by themselves and I have to factor. So first thing I see, there's no common terms, so I have to continue from that. This is just doing what we just did. Oops, and I wanted to get here because we're going to look at our table, right? This looks like something we've seen before, so I have to deal with my factors of 2 and my possible factors of a negative 55. So then I just start listing them in my table, right? And I have to just make sure that the order is all correct. So my possible factors of 2 are 1 and 2, and my possible factors of a negative 55. One set here is 1 and negative 5. 55, here it's 55 and a negative 1. Then it's negative 1 and positive 55. Then it's negative 55 and a positive 1. So you'll see that for each set of factors, when I have that negative C value, I should have 4 lines in my chart. So that's just something to keep in mind to make sure you don't lose any or forget any. We should always have 4 for each. And this is only if I have a negative value here. If this is positive, that's a little bit different. But if we have a negative, I should have 4 in my table. So we're going to continue looking at the possibilities here, and then we go back and see which one works, which is this one right here because I wanted W in the middle. So now I can go ahead and rewrite it. So I rewrite my problem, my equation, as W minus 5 times 2W plus 11. So now let's continue solving, right? And we set each thing equal to 0, which is my zero product property, and then I solve for W. So now I see I have 2 solutions, but only one of them is actually going to work. So now let's look at what we're talking about. So I see up here that W was the width of this preserve. Can I have a negative width? No, that's not a possible thing. So I know that I only want to be using this positive solution. So my width of my reserve is 5 miles, right? I know I'm dealing with space and area, so I can't have a negative width. That doesn't make sense, so I can get rid of that one. So that's why we always want to look at our answers in the context of the problem to see if they actually make sense and will work. Okay, so now here is your last little monitoring progress. Try it, right? Go back and see what you can come up with if the area is 136 miles. Nothing else has changed, but now try and figure out how wide this is for me. So now let's look back at our learning targets and see if we were able to accomplish those. So factor ax squared plus bx plus c. And one cool thing that we did too is we looked at, well, what if I have a negative sign here? Well, what if I have a negative sign here? Well, what if I have a negative way out here? I can follow my same steps to get the final answer. So it doesn't matter where the negative sign is, I can still do that. And then use factoring to solve real life problems. We were looking at the area of that game reserve, and we'll be looking at area a lot, seeing as we're multiplying things together. So now that we've gone through these and we've met our learning targets, go ahead and start working on the homework for 7.6.